Assalamualaikum and hi everyone. We are from Group G and today we would like to present about the industry involved in chemical process. Our team members consist of four, which are Joan Gojiaan, Lakshman anak lelaki Venus Warren, Majrin Adia binti Mazlan and Nur Nisa binti Ismail.
Now I'm going to present about the advantages for conventional processes and green root processes. So for the conventional processes, the first advantages is cost effective. Conventional injection molding is a faster, simple, and more cost effective way to manufacture basic plastic parts. If you are manufacturing simple plastic parts or your product have no special comfort requirements, conventional injection molding is a faster, simple, and more cost-effective solution. With injection molding, you can still produce extremely complex parts with uniquely customized features as we simply can't combine multiple materials like we can with overmolding. The second advantage is less scrap. Some conventional processes use less material and generate less scrap during production. And the last advantages for conventional processes is efficient plasticization. A breaker plant in the polymer manufacturing process can filter out contamination and unmolten granules and increase back pressure in the cylinder. So for the advantages of green root processes is reduce pollution. It minimizes the release of harmful chemicals and greenhouse gases during production. Green polymer synthesis often uses renewable resources, minimize waste, and avoid toxic reagents. For example, bio-based polymers derived from renewable feedstock reduce reliance on fossil fuels and decrease greenhouse gas emissions. So the second advantages for green root processes is energy efficiency. It often involves processes that consume less energy and lowering operational expenses. This is because green chemistry principles such as solvent-free reactions or the use of catalysts often make these processes more energy efficient and cost effective in the long term. And the last advantages is green root processes. It's reduced toxicity. It is reduced toxicity. This is because it limits the use of hazardous chemicals and improving the safety for workers and consumers. Polymer synthesis through green roots can exhibit desirable biodegradability and compatibility with composting environments and making them ideal for eco-friendly applications. Now I'm going to present about the disadvantages for conventional processes and green root processes. The first disadvantages for conventional processes is high initial cost. The energy-intensive corporations and waste of management increase the production cost. The second disadvantage is process rigidity. The initial setup and programming of injection molding machines can be complex and time-consuming, requiring skilled operators and engineers. This is because conventional methods may lack the flexibility to produce diverse polymers with tailored properties and limiting the innovation. The last disadvantages for conventional processes is potential for defects. While injection molding produces high quality parts with great precision, defects such as wrapping and voids in the final product are always a risk. This is because handling hazardous raw materials, intermediates, or catalysts can pose risk to workers. So, for disadvantages for green root processes is high initial cost. Is implementing green technologies often requires new equipment or retrofitting existing plants, leading to high capital costs. This is because Is developing and optimizing green processes can involve substantial R&D expenditures. The second disadvantage is process efficiency. Some green processes may have lower polymer yields compared to conventional methods. For example, green catalysts or enzymatic processes may have slower reaction rates and increasing the production time. And the last disadvantages for green root processes is technical complexity. It's scaling up green processes from laboratory to industrial scale can be technically challenging. For example, green catalysts or enzymes can be sensitive to temperature, pressure, and leading to operational constraints.
Right, for my part, I would like to talk about the block diagram in this Heath Glass company. I like to separate it into three types, where upstream, midstream, and downstream. Where upstream is sourcing and preparation of raw materials, midstream is processing and transformation of the polymer, and downstream is the post-processing, quality control, and final product distribution. So for the first part of the reaction pathway, we'll talk about upstream, which means sourcing and preparation of raw materials. Firstly is the raw material sourcing, where monomers are one type of the raw materials. So for example, monomers are like ethylene, propylene, styrene, and vinyl chloride are sourced from the petrochemical plants or refineries. And then additives such as plasticizers, colorants, and flame retardants are also sourced for the next step, which is polymerization. Polymerization is a process where monomers are chemically bonded into polymer chains. So they make it into a longer polymer chains to ease in the next process. This includes addition polymerization, which is chain growth in another term, or condensation polymerization, which is step growth, depending on the polymer being produced. And then the reaction is also initiated using heat, which is around 70 degrees Celsius, pressure, which is around 4 atomic pressure, and catalysts are also added, which can include titanium tetrafluoride and triethylaluminium. Yeah. And then the third step is compounding, where after polymerization, the process, which is the previous process, the raw material is mixed with other ingredients such as additives, which I stated earlier, the raw material sourcing part, fillers, colorants, and so on, to enhance its properties. Right. This is typically done in extruders or mixing equipment where the polymer is heated and blended with these components. Alright, for the midstream part, which is processing and transformation of the polymer, the first step is extrusion, where the polymer is mixed and melted under the temperature of 230 degrees Celsius and forced through molds, which dies to form continuous shapes such as film type of shapes, like film shapes, sheets, or profiles. This is typically done using the extruder materials, extruder equipments. Second step is injection and blow molding, where the molten polymer is injected into molds under high pressure of 200 bar, which is 200 megapascal, to form products such as containers, automotive parts, and consumer goods. In another hand, blow molding is used to create hollow polymer products like bottles. So the polymer is extruded into a tube, which is also known as a parison, which is then inflated in a mold and then cooled. For the third step, it's called film and sheet extrusion, where extruding the polymer into a flat shape, which we will shape at the injection part earlier, and then cooling the material either using air or water. It purely depends on the material that is being produced. And then stretching the material to improve its properties such as tensile strength. So in order to ensure the strength of the malleability of the product, stretching is done. So for the next part is cooling and cutting, where after the extrusion or molding, the polymer material must be cooled if it hasn't been cooled. If it's already cooled, then the next step is solidifying it to the final shape. So the cool product is then typically cut into desired size, which, like I said earlier, any part where we want to produce it into. So any desired size, such as pallets or further ways to, if you want to design it. And then further processing is involved to finish the products in its suitable and most required way possible. Right, the third and final reaction pathway is downstream, which is the post-processing, quality control, and final product distribution, where the quality control and testing is occurred first, where before the products are shipped out, as we all know, we have to test the quality of the product before it's been shipped out, right? So they undergo a quality control procedure to ensure they meet industry standards and customer specifications, like what the customer ordered for. So we have to make sure that we please the customers itself. Many steps are included in this quality control and testing, but mainly testing for mechanical properties such as tensile strength and impact resistance, like we did earlier, and then checking for dimensional accuracy, so like for the length of it, or maybe the shape, or maybe the curves of it, all should be tested. And conducting environmental tests such like UV or heat resistance, so we should make sure that the product is not affected or react with UV or heat resistance that can release a harmful substance or even gas. So the second part is packaging, where once the products are fully processed and they are successfully tested, the products that pass the test are fully processed, they are packaged for distribution. The packaging is done in a way that protects the products during transit. The products are packaged in a way to ensure that they are safely delivered to the wanted customers, such as companies or maybe industrial places and so on. So for example, polymers or plastic products are often packaged in large containers such as bags, box, or even shrink wrap bundles, like the ones that are shrink without airtight, and sent to various industries or retail markets, like I said earlier. So then distribution process occurs, where the finished products are then shipped to various industries or markets, including automotive packaging, medical, and consumer good industries. Alright, finally, the recycling process, where only some polymer companies, and Heath Plus company also does this, they recycle their products to focus on sustainability. And they recycle process where they scrap the polymer materials or used products and reuse in further production. So for the production of the later on production, they will use the recycled products to ensure the sustainability of the company is adhered, and to mildly save the environment. By this we can reduce the wastage of certain products. Alright, this can involve melting down using plastics and reprocessing them into new products. So by this we are also reusing the old products to make new products. And I said earlier, we can reduce wastage that can affect our environment greatly. So by doing these type of activities, the Heath Plus company not only satisfies the customers' wants and needs, they also save the environment by recycling and doing as much as they can to avoid further destruct to the environment.
So here I will explain about the issue related to the conventional chemical process. There are three issues I will discuss about, which is environmental impact, the economic issues, and the safety and health concern. So here there are three environmental impact that caused by the conventional chemical process. First is greenhouse gas emission, second is pollution, and lastly is waste management. First is greenhouse gas emission. Many industrial processes, including the production of polymers, often rely on fossil fuel like petroleum, coal, and natural gas as raw material. These fuels are extracted, processed, and used in the reaction of various chemicals and materials, including those for polymers. When fossil fuels are burned or processed, they release carbon dioxide, methane, and other greenhouse gas into the atmosphere. This gas trap heat in the Earth's atmosphere and contributing to the global warming and climate change. The emission of carbon dioxide and other greenhouse gases is one of the major contributors in climate change, impacting ecosystem, weather pattern, and biodiversity across the globe. The second one is pollution. Polymerization often creates toxic byproducts that can pollute air, water, and soil. This can harm ecosystem, wildlife, and human health if not properly managed. Lastly is waste management. Many conventional polymers, particularly plastic, are non-biodegradable, which means it cannot be break down naturally in the environment over time. This makes them a major challenge for waste management. When we dispose the plastic improperly, it will cause accumulate in landfill, rivers, ocean, and other ecosystems. This contributes to long-term environmental pollution. For instance, plastic in the ocean can entangle marine life, be ingested by animals, and disrupt the entire ecosystem. Next, I will explain about the health and safety concern. The first is about toxic material and the second is workplace hazard. For the toxic materials, in the process of polymerization, many monomers and catalysts are used. Many of these substances are toxic and pose risk to human health. Exposure to those chemicals, it can cause respiratory problems such as lung disease, asthma, or other breathing difficulties. Long-term exposure can lead to more severe health issues. So the next one is workplace hazard. In industrial setting where polymerization occurs, workers often handle volatile and flammable chemicals. These substances are reactive and can be dangerous if not managed properly. The use of such chemical increases the risk of fires or even explosions, especially if there is improper storage, handling, or accidental release of gases. This creates significant safety concern in the workplace. Last but not least is economic issues that included the high cost and material price. As we know, producing, processing, and transporting polymers require a large amount of energy and raw materials. Most of this energy come from fossil fuels like oil and gas. Because fossil fuels are used at every stage of polymer production, their reliance increases overall production costs, making polymers more expensive to produce. Then material price. The cost of producing polymers is directly affected by the price of oil and gas. As global demand and supply for these fuels damage, their price fluctuate. Since oil and gas are key raw material for many polymers, any price change can cause production costs to rise or fall, making polymer price is unstable.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurnisa binti Ismail, so I'll continue with my part, which is sustainability, impact of the green root process to the environments and humans. So for the first part, we need to know what is the impact of the green root to the environments. So the first impact to the environments is energy efficiency. Green roots prioritize the use of renewable energy such as wind power and solar. These help to reduce the dependence of fossil fuels. So the next one is conservation of natural resources. Conservation is the practice of caring for natural resources, include soil, air, water, mineral, plants, and animals. The green root also support the principle of a circular economy, such as recycling and reusing materials. The next one is improve air and water quality. Increasing recycling and upcycling rates is a critical strategy for addressing the issues caused by plastic pollution, but there are several techniques limitations to overcome. So the last one is minimize waste. Maintain and repair plastic products so that they won't have to be thrown out and replaced as frequently. We need to buy used plastic items to reduce plastic waste. Now let's move to the impact of the green root to humans. So the first impact to the humans is safest communities. The use of agromaterials to produce commercial goods through processes that are eco-friendly and non-hazardous encourages participation in environmental decision making and sustainable practices, raises awareness about the importance of protecting natural resources for future generations. So the next one is improve health. Turning to adverse effects of plastic on the human population, there is a growing body of literature on potential health risk. A range of chemicals that are used in the manufacture of plastic are known to be toxic. So the next one is economic growth. The manufacture of new resins and new application, which is produced in polymer production, but through upswing in recycle, both mechanical and advanced chemical recycling. These help on generating employment. So the last one is mitigation of climate related risks. To mitigate climate change and plastic pollution, alternative to fossil-based plastic can be explored. Bio-based plastic, which is extracted from renewable resources, partially or entirely, and biodegradable plastic have been suggested as alternative to conventional plastic. So all of this is important for us to learn what is the impact of everything that we do in our daily life to environmental and humans. So in my groups, we try to explain what is the impact of the green root to the environment and humans. So that's all from me. Thank you.
Last but not least, these are the references we use. That's all from us. Thank you for listening.